So we'll now move on to the next session, which is continuation of the previous session, and the session will be jointly taken up by Dr. Priyavrat and Dr. Debashish Roy. I believe Dr. Debashish Roy has already taken a session for you. Also, you know him. Dr. Priyavrat is working as a principal scientist and head at Central Arid Zone Research Institute. He holds a PhD with specialization in soil physics, and his area of expertise includes geoinformatics, digital soil mapping, spatial analysis modeling. So sir, for your session jointly, you can decide among yourself like how you will be going about. You have a total of 75 minutes allotted for this session. I will be giving you a heads up at 4, and you will be left with 30 more minutes to decide how to spend rest 30 minutes in answering queries, doing other things. So you have 45 minutes. I'll give you a heads up at 4. Over to you, sir, both.
Okay, thank you. And I hope Dr. Devashish has already joined also.
Yes, I am here.
Yes,
Okay.
he's there.
So before starting my presentation or the lecture on this topic, so hello, the meeting also. I am very much thankful to CMIT Academy for giving me the opportunity and invite me as a lecturer, as a specialist in this training session to give a interaction on spatial analysis on R. And before starting my presentation or the hands-on the R of the spatial analysis, just give a brief introduction about the R and my journey with R. And I started working on R just 11 years back in Netherlands, Wageningen University during my advanced research training in 2013. So earlier I was used to work in MATLAB programming codes, but once I introduced to R, it is so handy, so useful, and so applicable that I cannot hold the hand of R till today. And I have been doing this capacity building on R for quite a long time, and I have coordinated 3 training programs on R in Indian Council of Agriculture Research, funded by DST, sometimes funded by ICAR. So to all participants, I have a full belief that after some time, after getting introduced to R with this very small window for 3 days, hope everybody will start working on R, and one day you will be an expert on R, since R is a very evolving language package for doing anything. So I will just share a slide where I will give a brief about the hands-on whatever I want to do, because I will not spend much more time on talking on the PPT slide. So in the PPT slide, I will do something on the outline, and some of the output I will show to instigate your mind that how we can get this output. Then I'll quickly go through the R code, and I hope this R code has already shared with the resource material drive of the CMIT, so that everybody later on the participants can access those R and associated data, because some of the data is also already I requested my colleague Dr. Devashish to share with CMIT Academy so that it can be accessed by participants also. So this is my outline of presentation, concept of spatial data on R. Some of the basic concept I want to introduce, because a lot of time I spent to understand the spatial data framework in R before going jump into the R. Okay, so what does it mean actually? So that conceptualize will always help you in future whenever you will do on your own, because so many things are available on the net. Then overview on different packages of R handling spatial data. And I can assure you every 3 months, this package will change on, because there is a very live community working on R. So many updates, so many changes in the packages are happening so quickly. So if you are not deeply involved on this part, you will be detract after 6 months time or 1 year time. So again you have to be in track and what is the progress and update has been made. Then handling spatial data with SP package, the older package of R, using a classical example of R on spatial data, that is Muse River, Muse Grid. Then spatial point data and polygon data using the recent package SF package with example from Arid Western India. I will show some demonstration. Then handling the raster data using SF package using digital elevation model of 1 kilometer resolution of Arid Western India. Then giving some exposure on the handling Google Map in R at the last. So before going into this presentation, these data types and the class, it is very important to know before going to the R package directly and opening a spatial data object in the R. So you can see from this you see there are different types of data types, and everybody knows, I hope, that what does it call as a spatial data or the GIS data in terms of vector and raster. So point, polygon and lines, these are always called a vector data, and grid and pixel are raster data. So all these data types, points, multi-points, pixels, grid, lines, polygons, all these data type can be handled by R using different class. And actually in spatial analysis in R, we call it as a class and methods. So for points, the class is spatial point. And if this point is with some data frame as an attribute, we call it as a spatial point data frame. So how we can create the spatial points, how we can create the spatial point data frame, then how we can create the spatial multi-points, and then multi-point data frame. Then spatial pixels do not have any attributes, only the lat long information will be there. But if it is associated with some data, then it is called pixel data frame. And similar is the case for spatial grid and spatial grid data frame. But this difference between spatial pixel data frame and spatial grid data frame, I will explain later on in my demonstration that what is the difference between these two. Because sometimes in R, when you open a data frame, different classes may be shown. So what does it mean actually and how we will handle it? That depends on if you have thorough knowledge on the background data. Then similar is the case for line, spatial lines, and spatial polygons and spatial polygon data frame. So for example, spatial point data frame, how this data has been structured. For example, this spatial is a class, and spatial class in R is actually defined by two things: big box, this bounding box, left lower corner and the right upper corner. These two coordinates is actually giving the bounding box of that spatial object. So it should be defined. And the prod for string means what is the projection and the coordinate reference system that is been stored here. So this actually defines the spatial entity of a data frame. Then if this spatial is merged with coordinates of several points, then it will come to the spatial points. And with this spatial point, if you put some data frame in that spatial points, now it becomes a spatial point data frame. And I will give an example from this point stepwise how we can create a spatial point data frame to be handled in R. Similar is the case for spatial line and polygon data frame. For example, line defined by different coordinates, starting coordinate, ending coordinates, if it is a linear line. And if it is a curvilinear line, then there will be several nodes. And for every node, there will be coordinates. So if there are several lines, then one line and then another line, so there will be an ID. So multiple lines are then converted into a spatial object. Then if the spatial thing is added on these lines, then it is called a spatial line. Similarly is the case for polygon. And if the spatial line and spatial polygons are linked with some attribute data, then it becomes a spatial line data frame and spatial polygon data frame. And here is also example for spatial pixel data frame and the spatial grid data frame. I am not explaining because it is the same. The spatial bounding by defining by this bounding box, and the projection and coordinate reference system, and joining one by one, we can create this spatial data frame and spatial pixel data frame. So these are the different packages available in R for handling the spatial data. I have listed only 5 here, but there are so many. But I am giving this example. This SF is the most latest spatial package of R which handles the spatial data. Earlier we are using ASP package, and where this raster, RGDAL, every packages are associated with this ASP, but now it is overloaded with or added with SF package. And these are some visualization tool: raster visualization, R Google Map, R World Map. Then I will go in some of the brief result which I will show in my R code sharing, that how this data has been created. For example, this is a spatial data handling using the SP package. So I will use this music grid. And what does this music grid understand? I will explain in that demonstration. Then using these small codes, I can prepare different spatial object and plot. Then from this spatial object, on the polygon object, we can also prepare the grid of spatial point data frame, spatial pixel data frame, and also the spatial grid data frame. Then there is a soil series database available with us, which I have shared with all the participants, I hope. And this is called the Soil of Arid Western India Legacy Database. And I will try to make from the Excel sheet how we can prepare a spatial object, and then you can do a lot of spatial analysis on this part. Then the spatial polygon data frame with the existing polygon boundary map, we can overlay and we can do some analysis on this part. Then as a raster example, we have taken a digital elevation model of 1 kilometer resolution from arid western India, and I will try to give some example or reading this data and then doing some operation. For example, the clipping of the some portion of this dam and create a new dam, and also doing the clipping by using a polygon from that raster, and how to create a new digital elevation model, and also trying to change the projection of this model or the digital elevation model, how we can do in the previous slide. Then at the last part, I will go for plotting the spatial object, how we can do. For example, using the R Google Map option, then My Map, Get Map option, and also preparing some maps of Rajasthan. So, and from the R World Map, Map View, and this digital elevation model and the spatial locations of the soil series database of Western Rajasthan or the arid Western India, how we can plot in the Google Map, all things will be displayed at the last part of my presentation. So this is in nutshell is the presentation slide. Now I will quickly go through the R code, and please feel free to say that because this is the most important part, and I will try very precisely. This is a small code, and I hope everybody is seeing this R page. I hope everybody is.
Can we have thumbs up
confirmed?
from, yeah, can we have thumbs up from participant if they're able to see? Quick thumbs up in chats or a yes. Okay, we received one. Can we have more people telling us that
Yes.
they're able to see? Okay, we have people seeing it.
Okay, okay, okay. So, try to follow this R code now, where we can do a lot of play with the R spatial analysis. So you go to this first line, clean memory.
Sir, sorry to interrupt. I believe someone's mic is on. Any of the participants, please check if your mic is on. Please keep yourself on mute. We're getting a lot of background noises. Or Vivek, is there a way to mute all the participant? I see for great Chakravarti.
Yeah, Nakibullah's mic was on, so I switched it off now.
For Greta Chakravarti, also we need to switch it off. That's still on. Because I don't think I
Okay.
have the right.
Yeah, I will check with Greta. Okay.
Oh, all right. Thank you.
Yeah.
So please carry on.
Okay. So these R window or the R studio, this is the R script portion. This portion is the R script portion. Then this is the console, and this is the environment window where all the data variable are being whatever has been opened, it is shown here, and this is the plot window. Okay, this has 4 sub window. Now we will run one by one. This first portion is very much necessary to run before starting any type of R code running. Why it is important? Suppose now you can see in the global environment, so many variables are open. Okay. So before starting my R script, I want to ensure that whether any variable is there in the global environment or not. If it is there, I should remove all the environment first, because some of the variable in your R script may overlap with the already existing R script. Okay, then you cannot judge whether your R script is working properly or not, because it is override by some of the same variable name. So using this command, I can clean all this environment. Please look at this portion. Now it is clean. You see, environment is empty after running this. Then second is the set of working directory. I think Bappa has already told about this thing. I do not know, but I am just repeating. Your set working directory is very much essential. Now you can see this is my working directory where I will most of my data are stored, from where we will access. So you can see in this folder in the E drive, so there is a folder called CMIT training on R. So whatever data I will access in my R script, it should be available in this folder, otherwise it will not work. So this working directory is to be defined here, and now I have to change it to my working directory. So here you can see there is no error, and the working directory has been changed to this current working directory. Then I will open the library. So I already told that SF library is the most advanced spatial data handling library. So I will check it with the library SF. Now it is loaded. So without loading this library, if I run any code, it will give some error. Okay, then I will actually open a data called muse.grid. But before that, there is a something written in this part. You can see. So these are all start with hashtag. So hashtag means this is a comment line. This is not run by the R code. So descriptions of this grid is written here. So the music grid data frame in R is a grid with 40 meter into 40 meter spacing that covers the music study area. It has 3103 rows and 7 columns. So this data frame contains the following column: X, Y, distance, F frequency, part A, part B, and soil. Okay. So this data description, I have an idea that this data means these are the 7 columns in that data. Okay. Then I will open this data, but before opening this data, I should be very much assured that the library SP is loaded. Okay, suppose I am opening this data, you can check it. I have opened and it is opened here because I have already loaded the SP package earlier. Okay, then you click on this data, music date. So as I described, it has 7 columns: X, Y, part A, part B, distance, soil, and flood frequency. So all this data is available in my code. Now I can check whether this is a spatial data or it is a simple data frame. Okay, then I will check what is the class of this data. I will run this code, this portion. So the class is, it is a data frame. You can see here it is showing as a data frame. Then summary of this data, it shows that for 7 column, what is the minimum value and what is the descriptive statistics for every column. Then I will convert this data frame. You can see here it is also a data frame now. Now once I will convert it to a shape object or spatial object, then I have to define the coordinates of that spatial object. You remember, it is very clear that whenever you are converting a data frame to a spatial data frame, the coordinates needs to be defined first. If coordinates is defined, then only your data frame is converted to a spatial data frame. So here I am defining the coordinates x as the x coordinate and y as the y coordinate. Means in my data set, this x column will be the x coordinate and y column will be the y coordinate. So I have to define here. So I want to convert this music grid data by using this function st as sf by defining the coordinates x and y, and I will run this line. Now you see this music grid has been converted to a sf object. How we can check? Now we can check the class. Okay, this class, okay, this class I will check it. Now it is showing it is a sf object. Earlier it was a data frame object. Now we have prepared this is a spatial object. Now when you see the summary, so here you can see extra 1 column has been added. That is called geometry. Earlier this geometry column was not there. So that means geometry is defining the spatial component of this data frame now. Now it is a spatial object. Now I can plot it. Suppose I can plot it. So you can see here this plot has already come here. I can also zoom this plot.
So just for participant, whenever sir is asking something, you all can let him know by giving a thumbs up or by saying yes, so that he also knows that we are moving at a right pace.
Okay. So I hope everybody is following me in the R code.
Please let us know if you're following sir well. You can open your mic, say yes, or give a okay in the chat.
Yes,
I don't
please,
see any.
try to be interactive. Otherwise, because this is
Yes.
a demonstration type of thing, so if you do not interact, I cannot also assume that everybody is understanding or not, or whether I am doing going in the right direction and the wrong direction.
Okay, we have a lot more replies from yes from everyone, and I would ideally ask people just to unmute
Yes,
themselves, say
yes,
yes.
yes.
Sir can hear you. He cannot check chat every time, right?
Yeah,
Just
yeah,
unmute yourself, say yes, I get it, and then mute yourself back. Please do it. Please, I'll request everyone to use your mic camera more often. But
yeah,
be
yeah,
mindful, don't keep your mic on all the time.
yeah,
Next time, sir asks something, please unmute yourself and say a yes or no.
yeah, yeah. So you can see here this spatial object. Now it was earlier it was a data frame. So this part A, part B, dist, soil, and flood frequency. So these 5 attributes has been converted to a spatial component. Part N and part B is the half portion of the Muse, that catchment area is part 1 and part 2. Dist is the distance from the Muse river, and more is the red line, lesser is the distance from the river. And this is the soil pore, and this is the flood frequency potential of that Muse river basin. So this is the spatial component we have been converted from the simple data frame. Now same thing we can do using the SP package, and which one is the earlier package, and most people are using this SP package and lot of people are still continuing on it. That's why I am given example of the SP package also. So again I will open this data, this music grid, then I will check the class, it is showing as a data frame, then I will check the summary and it will show the data frame summary, then I will define the coordinates. So here, unlike of SF package, here is the difference. In SP package, the coordinates of this object is defined in terms of C, X and Y. So in my music grid data frame, now I am defining two spatial components. Now it will be converted to a spatial database. So now we can check whether it is a, so now it is a spatial point database. It is showing that using SP package we have converted to a spatial database, but still it is a spatial point database. Okay, now I will convert this to a grid database or the spatial pixel database. Using this command, if I write gridded music grid true, then this spatial point database will be converted into a pixel database. Okay, so now you can check. Now it has been converted to a spatial pixel database. You can see here. Okay. So from data frame to spatial point data frame, then to spatial pixel data frame I have converted. Then I can convert this to a grid data frame using this command music grid as spatial grid data frame. But before going into this line, I will plot this music grid pixel data frame with a Z column is the flood frequency. You can just look at this column and look at this attribute. So I am using SP plot to plot this music grid, which is now a pixel data frame, and I am plotting from that pixel data frame. There are 5 attributes. I am plotting the flood frequency. So I have written as a, this title of this plot is the flood frequency. So now I plot. You can see that it has been opened. So it is a flood frequency. So earlier I told there are 3 categories of flood frequency, 1, 2 and 3. So this is now plotted. Okay. Now we can also plot, suppose for example I want to plot soil. So I will change here soil. Then I will plot. So it has been a soil, but I have not changed this title. It was a wrong. So I will change here. It is a soil map I am preparing. So I will write soil. Soil of Muse River catchment. Okay. So you see, now it is a soil of Muse River catchment. So likewise, then I will convert this pixel data frame to a grid data frame, and after running this code I will explain what is the difference between a pixel data frame and a grid data frame. Okay, so now I am converting this line, this one, to making it as a full grid. Okay, so now I will check what is the class. So you see it is now spatial grid data frame. Earlier it was a spatial pixel data frame. Now it has been converted to a spatial grid data frame. So if I check the plot of this also, I can do the plot. Okay, soil. Okay, is it okay for you? Okay. Then now I will clear this very specific difference between a spatial pixel data frame and spatial grid data frame. For example, here I can see there are a lot of grids here. Okay. In the spatial pixel data frame, so these portions are the outside the boundary. So this is called the NA value. There is no data in this position. In the spatial pixel data frame, what it does, it store where there is a non-missing value. Means there is no NA value. So for information, for only those pixels will be recorded in a spatial pixel data frame in terms of X, Y, and the attribute value. So that means for every location, every pixel, it will store the data. But in case of spatial grid data frame, it will ask the grid topology in terms of the cell size and the lower this corner and this corner. And then only it will divide it into the lot of grids, and for every grid data will be stored, whether it is inside the boundary or it is outside the boundary. In outside boundary, it will store the NA value, and inside boundary, there is a specific value. Either in case of soil, it is 1, 2, or 3. Either of these 3 values it will be stored, and outside it will be stored NA. But since spatial pixel data frame stores lot of data, because for every pixel it is saving the data on the X coordinate, Y coordinate, and the attribute value. And that's why memory size requirement is much higher in case of the spatial pixel data frame, and that I will check now. Okay. Suppose this is my data frame. I will again go from the data frame. This on the data frame. Then I will class, then summary, then coordinates to a spatial point data frame. Then now it is a pixel data frame. Now I will check the size of this data. You see, there is a command object.size. So I will check whether this music grid data, what is the size. So it shows it is 5,66,304 bytes data. Okay. But of the same grid or same raster, if I do on a spatial grid data frame, I converted in a spatial grid now, and now I will check what is the size. It is now 2,66,296. You see, there are almost half reduction in the data space, because in my area, in this area, 50% area are blank. Okay, this whole rectangular, there is some portion only data is there. So that's why in the spatial grid data frame, less amount of data has been stored. Okay, then I will go to second example. Second example is this one, reading a spatial data frame and then converting it to a data, spatial data. For example, this data I will open. So this is a just notepad data. Okay, this is a data, and this data has several columns starting from serial number, ID, soil series, series ID, long, lat, X, Y, top, bottom, sand, silt, clay, organic carbon, calcium carbonate, pH, EC, bulk density, field capacity, then calcium, magnesium, sodium, potassium, and cation exchange capacity. All this data are stored in this legacy soil data of the arid western India. So this is a huge database. Now I want to convert it into a spatial component so that I can do some analysis on this data. Okay. So I am assured that this data is available in my working directory, CMIT training R. Okay. If this data is not here, suppose I cut it. Okay. And I put it in the desktop. Suppose I put it here. Okay. So this is here now. Okay. Now I run this code. Read table, legacy data, header is equal to true. Okay. So what does it show? It shows that error in file cannot open the connection. In addition, opening package, no such file or directory. It says that this file is not available in the working directory. So now I will copy this data to my working folder here. Okay, now it is available here. If I run now, it is open. Okay, so that means this data should be available. So this is the data I was opening in the notepad. Serial number, ID, soil series, series ID, everything in this data is available now in my R data frame. Now I want to convert this to a spatial object using a SF package. So I am defining these coordinates of this data, long as the x coordinate and lat as the y coordinate. And try to remember and be very clear on that which one is to define as a x coordinate and which one to y coordinate. Lot of people use latitude as the x coordinate and longitude as the y coordinate. Then your whole data frame will be 90-degree flipped and it will not match on any type of GIS environment. You see, longitude actually it changes in this direction, in the x direction, and latitude in the y direction. So that's why latitude always should be in the y direction and longitude should be in the x direction. If I change it, then it will give a wrong spatial object. It will be tilted like this thing, 90-degree tilted, and it will not match in my area. It will go in somewhere else. Suppose if I define latitude longitude as 27-degree, where it will go? It will go somewhere in the Greenwich line. Okay. So using this command, I will just convert it into a spatial object. Now I can check these are the data available. You can see these are the column available and specifically look at this position and be sure that your data frame is now converted into a spatial data frame because geometry one column is added. Earlier this column was not there. Okay. So I will check whether this has a data frame or not, this projection or not. So using this command CRS st_CRS, I can check whether this data has a projection or coordinate reference system or not. Because I have already defined here CRS is equal to 4326. This code means this is the WKT code for geographic lat long coordinates, and my data is was in lat long coordinates. So my data is now with the projection of long lat with the datum WGS84. That means my data is now with the right projection and right coordinate reference system. Now I will plot. So here you can see lot of windows have opened and one warning message has also come. Okay. In warning message it says plotting the first 10 out of 23 attributes. Use maximum dot plot is equal to 23 to plot all. Because in my R by default this plot window it will accommodate only 10 sub window and I have 23 attributes in my data. So it is giving warning message that you are trying to plot a spatial file which has a 23 attributes and you are trying to open it in a R plot window. Okay. Then if I want to specifically open only one property, then I can use, for example, sand. Only sand I want to plot, then this code will generate only the sand plot with a axis value. So this is the sand plot, and this color code has been given for different values of the sand content starting from 20 to 80. Now if I want to plot only the geometry of this spatial file, then we can plot only geometry, means only the locations of these spatial files have been opened here. These dots are in a spatial domain. Okay, so this is a spatial data file. Now we have converted into a spatial file. Now I am going to the one polygon file, edit Western India. So it has already been saved here in this data file. I will check edit Western India, this shape file with the auxiliary file, it is there. So then I will open this st_read using this function. I will open this AWI. So it is now reading layer. It has been opened, and I will check whether this has a coordinate system or not. So it says it has a long-lat coordinate system. Okay. So I have to check if I want to plot this and my previous the point data file on the same projection, then these two projections should be same. If this is in suppose meter coordinate system and that was in lat long coordinate system, I cannot plot these two plots on altogether on a same platform. Now I plot this edit Western India. So this is the boundary file of edit Western India. Okay, this is one agroecological region of India, edit Western India. Now I will change this plot with some addition. Suppose axis has been added, latitude, longitude, everything has been added, and I have changed the color. This color is in your hand. Whatever color you want to try, suppose you want to try blue or red, suppose it's red, automatically it will be in red. You can see now it is red. So any color combination you can do. Then I will plot the geometry of this edit Western India using a gray color, because here I have written as a gray and axis is equal to true. And in the next line, I will plot on this file or on this map the point file we generated earlier. Now we see. So this is the gray color plot of edit Western India. Is it visible?
Is it visible for the participants? Okay, we will ask the participants to say and not type in the chat this time.
Whether it
So
is visible?
can
Yes.
one of you
Yes.
open your mic? Okay, that is better. Please use your mic more often.
Okay. Okay. Now it is. I have opened the edit Western India, the spatial file. Now I will plot on it the spatial point file, whatever we have generated earlier. So now you see all the spatial point file which I generated earlier. Now it is overlaid on this map. Okay. Now there are so many commands available in your hand. So this PCH is equal to 3. I have written. So this is the point characteristics. Suppose I make it to 16. So different codes are available. You can see the symbol will change. Are you looking at it? It is changing. Suppose I put it 10. So different symbols will come. Okay. So suppose I put it 1. So different symbols will come. And if I want to change it to red, purple will come. Okay. So now it is in your hand how you want to put it. So up to this point, I hope everything is okay. Now we have created a spatial point file from the original database. Then we have created another polygon file, and on that polygon file, I have overlaid my point data file for which database is available. Okay. Up to this, I have handled it. Now I am going to the raster part, because I have already spent around 35 minutes time. I hope another 10-15 minutes I will finish. Then I will hand it to Devashish to do the next portion. How much time we have now, Jinat?
Yes, so I was just going to remind you, you have 6 more minutes. Then it's only half an hour left for both of you, both Debashish and you, to
Okay,
wind
half
up
an
the
hour
session.
left. Yeah, I already talked with him. He will take around 20 minutes. So I will take 10 minutes time. Okay.
I'll
So
give you a reminder in another 10 minutes so that
yes,
you're
yes,
on.
yes. Yes, that will be very much helpful. Then another library is required for handling the raster file. So Terra. this Terra, it needs to be opened library. If it is not available in your system, then you can install packages Terra. You have to do it. Okay. So it is error in install packages. It is already loaded, so I am cancelling it now. Okay. Now I will open a raster file called dem 1 kilometer underscore awi.tif, and this file is also available here. Where it is available? Dem 1 kilometer AWI with a 2110 kilobyte file. So this is a GOT file. I have put it in my folder. Now I will open it. Okay, it is open. Now I will check what are the attributes associated with this raster file. So very carefully read this portion. Before going into analysis part of the raster, you read this portion very carefully. So it says that it is a class of spatial raster. It has a dimension of 1081 rows, 998 column, and one layer. So n row is 1081, n column is 998, and number of layer means 1. So sometimes in the raster there are so many stacking of different layers. In the remote sensing images, maybe 10 layers are packed in a one layer, one image. So in that case, number of layers it will be more than 1. Resolution is 0.00833. So it is almost around 1000 meter. But the extent is this lower limit and upper limit extent, x minimum, x maximum, y minimum, or y maximum, it has been given. Then coordinate reference system is long lat with the EPSG code of 4326. The source of the data is that file dem 1 kilometer TIFF. Name of that file is dem 1 kilometer AWI. Minimum value of this data is -11. Maximum value is 934. Okay. So this is now a raster file. Definition has been given and all the characters of that raster I have given. Now I will check whether CRS of this raster file, what it is. It shows it is a lat long. Then what is the number of cells? 1078838. So it is the multiplication of n row and n column. 1081 into 998. It will come to this value 1078838. Then histogram means what is the histogram of this raster? That most of the values are in this position, in the lower portion. Suppose histogram actually by default it is getting a some sampling of the raster it will take, but if you do the full histogram, you can define the maximum number of cell by defining this max cell is equal to n cell of dem. I am not going into that part. Now I will plot the dem. So this is the digital elevation model of arid western India. Okay. It starts from 0 to 1400 meter from mean sea level. With a very high distance at these fringes, which is a hilly area, and these are the most low elevation area. So this height actually gradient from this side to this side. Now I will project this dem to another projection system. Suppose from the digital elevation model, most of the time we want to calculate the slope, and slope is actually the vertical distance divided by horizontal distance. And suppose you are calculating the slope from a dem using a lat long projection, what will happen? The elevation will be in the meter and the horizontal distance will be in degree. Then the slope will be somewhat absurd values it will come. It will not give the error, but it will calculate, but the slope value will be meter divided by degree. So that's why I need to convert this raster from latitude longitude coordinate system to a system in a meter coordinate. So my meter coordinate, it is defined is the UTM 43 zone number. So this is the EPSG code. This code you have to remember and for your own area, and you can search from the net that what is the UTM code number for your area. Suppose I am now converting to a UTM coordinate, and now I can check that this is the extent it has been calculated now. Okay. If I do it on 42,
Can you repeat this part, please?
yeah,
Can you repeat this part?
repeat. Okay, sure. Suppose I am now converting this dam. This is a dam of arid Western India with a, you can check it, it is in resolution in terms of degree. Okay. See, because it is a lat-long coordinate system. So everything written is in degree in the spatial component. Means x component, it is in degree. But digital elevation model says this y component or the z component is in meter. So if you calculate slope, slope is always the vertical distance divided by horizontal distance. So in case of, if you are using the slope or calculating the slope from this lat-long projection system, the slope calculation will be erroneous or it will be an error. So that's why we need to convert this dam to a meter coordinate system for further calculation of any terrain attributes. So here I am converting by using project. That means I am reprojecting this raster file to a coordinate system with the UTM, which is a meter coordinate system. And 32642, it is the EPSG code for UTM coordinate system. So now I am converting this to a meter coordinate with UTM projection. I will check that now it is in meter. You can see the extent, it is now in meter, and my coordinate reference system has been changed. Okay, now I will plot it. You see earlier, you see the spatial component, it is in meter now. Okay, earlier it was like this: 70 degree, 75 degree, 22, 24, 26, 28, 30. So this was in lat long, but now it is in meter. Okay. Then I will do another exercise, how to clip a dam from this existing dam. And for this purpose, I need another library called raster. So I have loaded this raster. Then I will draw and extend from the existing. Look at this portion very carefully. I will do a crop box from this dam. So once I will click on this line, so in this window, one crosshair has come. You see? So now I have to define the area. Suppose I click on one red spot has been added, another red spot has been added. So one rectangular box with red line has been identified. Now, if I click on this crop box and if I plot, so this dam has been clipped from that existing dam. Okay, from 200 to 400 with that existing dam. And I can do it by simply writing the extent also. Right? Likewise, this one crop box 2, it will put another clip from that existing dam. And suppose I want to do as a polygon extract from that dam. Suppose, for example, Jodhpur is a district in the arid Western India, and I want to click a portion for this whole district from that dam. What I will do, I will just plot that where this Jodhpur district lies in the arid Western India. You can see Jodhpur district lies here. Okay. So this black black line boundary is the Jodhpur district in arid Western India. So I will clip a dam from that existing dam. So now I plot. So this is the digital elevation model of Jodhpur with 150 to 400 meter elevation. Okay, so up to this portion, I hope it is clear. And if there are this time is over, Jinath.
I think we have like a minute left for you. Then we need to
Okay.
move on to the Bashish. Yeah.
Okay, so then I will quickly go. I hope everybody understands this part, this spatial data component, this the polygon data, the point data, then raster data. And I request all of you, because I have shared all the data. Okay, in your off time, you try to run these codes on your own and try to get some error message. Error message is very important to learn, because R, it is not that always it will work perfectly as you desire. It will not happen. If you are fully expert also, sometimes some error will come. So my request will be to all participants, as I also received 10 years back from my supervisor when I learned it, that you try to read the error first. What does it mean? And what is the warning message and what is the error message? If you try to analyze the error message, you will learn more. And in R, there are so many things available where you can learn so many things. For example, if this command is available, if I go to the next of this command, and if you put tab, this portion will open. And then if you put F1, one help file will come. Here it will help file will come. So every command it is available. So you will be automatically learning something. So you need to just go to jump into the R and try to learn every command. So suppose for example this crop command, what does it means? So in the crop, after opening bracket, if you click your cursor and if you put tab, this portion will open and then you press F1. So this F1 will open, then you click on crop. So all these descriptions are given here. Every command it is available. Okay. So you can check every command, whatever I have written, you can check on your own in your own desktop. Now I will quickly going to some of the visualization of the images just within 2 or 3 minutes. For this, we need a package called JPEG. Okay. For example, this portion I will run. So this is the whole world visualization in terms of GIS file. Suppose you are working on a large metadata file of the whole world and you want to specially point those files in the whole world where my data points are there, you can use this type of maps. Okay. And suppose it is showing some updating of the packages, because earlier I installed, now it has been uploaded. So every time it is being updated very quickly. Now I will go to the India map. Okay, now it is installing these packages. Just it will take some time. Meanwhile, I will. Okay, it has been done. Very small package. So now India map. Okay, if it is taking some time, I'm not wasting this time, but I have at the end, I have given two links. Okay, two link to just okay, this now not working properly. So I will request you to go to this link. Two link I have given. One is on GitHub. this link you should go very carefully. Using spatial data with R, it has been written on February 21, 2024, and this page is giving lot of information on the spatial data handling on R. You can see in the left side menu bar the SF package, creating a spatial object, loading shape files, raster data, attribute, reprojecting, everything is available here. And second file, this GitHub, R spatial, plotting simple features, plot method of different attributes and data file. So these two pages I have given as a reference to read. And lastly, I will show one interesting example from the R. You know, from R we can write the manuscript also. I can make my presentation also from the R. Whatever script I have written, I can run and I can generate the PowerPoint presentation file. So there is a option called Arc Markdown. Okay, if you click on it, it will choose what you want to prepare. HTML document you want to prepare, or PDF document, or Word document. Okay, from this document, suppose it is a trial version, I will run it HTML version. So then if it is okay, then one page has been opened untitled. This is a markdown file, and if we neat means compiling the whole document, so it will give an output of it is running in the background, and it will give some HTML output. You see, from this R code, I have created an HTML page now. So whatever I was running on the R, it has been converted to a HTML file. So similarly, we can do on PowerPoint also. For example, hard markdown, and if I click on the presentation, and if I click on PowerPoint and untitled PPT of CMIT, okay. So one identical file has been opened. I have to neat it, giving some name CMIT. CMIT 1. You see, one PPT file has been opened, and it has been actually writing all the things whatever available in my R code. Okay, so all these things from your single R command, I can do Word file, PDF file, PPT file, HTML file, everything I can do. So if I write my R code very properly, if I click on the Word, then manuscript will be generated on your own, and whatever data has been filled in that R script, the Word, the table, figures, everything will be accordingly as per this format. And most of the publication, the international publication group are now wanting this type of code as a supplementary code to check your in the review process. So with this, may I stop here, and I can hand over to Devashish for quick go through of his presentation part.
Yeah, I think okay. To Debashish Chakrabarti, like for the session is time to end at 4:30, but since we have sort of less time for Debashish Roy, what do you suggest? Because we have a 15 minutes break after this session. Should we give more time to Debashish, or should we make it 20 minutes only?
Our Chinath, our next Dr. Priyo only, he will continue at 4:45. Huh? So still we have
Yes.
15 minutes to go. I think that we can keep it short of 15 minutes break. Rather, we can keep it at 5 minutes break or 10 minutes maximum.
I think we should
because
give
so
it
that
10 minutes
Dr. Priya also will be he also will be
because
free.
it's also a long session for the participants. So back to back, there
Yeah, I
should be a
understand.
good 10 minutes for them
I
as well.
understand. So
I think,
let Devasys give a chance of 15 minutes time.
yeah.
He may explain something.
Mhm.
Uh, okay, and then we can break.
I think it works well. Debashish, you can take over. We are starting with 15 minutes in mind. If you take 5 more minutes, it's fine. And then we would like to ideally
Yeah.
give the participants a break of 10 minutes before we move on to the next session.
Yes,
So
yes,
over to
that's
you,
good.
Debashish.
Yes. Uh, I am audible.
Yeah, well and good.
Dev,
Okay, I will take 15 minutes. I will share my biggest screen. It's visible.
Yes, we can see your presentation. I would request participants to interact with Debashish and help him understand if you're doing fine with him or not.
Voice is very low. Voice is
Debash,
not audible much.
even for me, it's low for you. Could you be a bit more louder?
Now it's okay.
For me, it's fine. Is it good for all the participants?
No, actually, very low voice is coming. Other participants can confirm.
Yeah,
Yeah, their
please
voice is
confirm
low. Their
because it's
voice is
fine
very
from
low.
our end.
It's okay for me.
I think it's more or less okay for everyone. I believe some people are facing some issue or
Okay for
with
me.
system there is an issue. It's okay for most of the people. So Devashish, I guess you can continue. Those who are still hearing less, I believe the problem is at your end.
Okay. Thanks.
But yes, since you're using your headphones, I would really request you not to move back and forth because that will create disturbance and also disturb the level of volume. So I think that is what is creating problem, you using a mic, hand mic, and moving back and forth. Devash, it's now low for me too. So is it possible that you not use those headphones, like is it possible?
It's
Because I think while you're taking the session, you might be using hand gestures and then you might not be able to like hold it and keep moving back and forth. That is creating disturbance in the level of volume.
okay. Uh, but I have no available that any microphone. So I will go through this.
Okay.
No
Okay,
problem.
just try not to move away from the mic.
Okay. Okay. Shall I start?
Please go on.
Hello everyone. Uh, these sessions I will cover the climate data analytics in our studio. So I will highlight some four key points which I will cover in this session. So first one is the annual average of global NDVI for spatial data. So how to average the annual NDVI from day to month or month to year. So here I have done in R. Then correlations in R for spatial data. Then man-candle tree analysis for historical time series spatial data. Then plotting spatial data in Panoply software. So my windows are visible.
Yes.
yes.
So first of all, we know how we do the average, average the NDVI global NDVI data. Suppose we have daily NDVI data and fortnightly NDVI data, and then monthly NDVI data. So how to we this use for spatial analysis using the average. This is for climatology. They have used basically monthly, yearly, or seasonally data. They have make the daily data to monthly data, then monthly to seasonally, and seasonally to annual data. So how it can be performed by R? So we know that the climate in climatology, they they have taken the 30 years average of climate data. So for time limitations, I have shown you that only 10 years average data. How I do the monthly average using the global using the R of global NDVI data. So this is you can see this is a monthly average global NDVI data, which is I have taken 1982 to 1991. Okay, this is the monthly average data. Okay. So from there I have to make in yearly average. So how to do in R? uh, you know that there is naming convention is there. So you can see there is the month and year. Okay.
And I think so. Slide is not moving.
Right. Okay. I am not in slides. Okay.
Okay, but here we are only the PPT is visible.
PPT is
The R page is not visible.
What you can do, you can stop your share and share it again, and this time you share the screen, and from screen only you can handle the different windows. Okay.
now it's visible.
Yes, sir. Now it's visible.
Now it is visible.
You can see here I have averaged the fortnightly NDVI data to monthly average data. Okay, so this is the file name which I have given according to the year and month. Okay, this 01 means month, and this is 1982 means this is years. So I have taken 11 years to average the NDVI data yearly. Okay. So how to do this analysis? You have to perform. Okay. So using this code, you can average the monthly NDVI data to average annual average NDVI data. So my R code is visible to all of you.
It's visible.
Visible. Okay. So first of all, we set the directory. So from where the file are there, so it takes automatically from that folder. So if we run, so it's shown the set directory already set. Okay. For the spatial analysis, we need the some basic library which is called raster NSP. This is a basic library which we used for raster analysis. So we take the years from 1982 to 1991. Uh, so then we define the month as a vector. How it can be defined? It can be defined using the function sprintf, where 1 to 2 means that 1 to 12 month uh, can be executed in sequential order. Okay. So how it's we can do the in the monthly to annually conversion. Okay. So for this we using the loop. It's basically consist of uh, 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 set of statements we are together, which creates block code. So within this loop, I write the statements. From there, we can get the monthly iterative in the iterative process. We can select the month and year wise data within this loop. Okay. So the in this statement, month in months, what it means? In the months means in month vector, the current variables is month. So it takes sequentially in orderly the data from the folders according to month wise. That is month wise starting from 0, 1, 0, 2, 0, 2 like that. So first of all, I run this month vectors. So we can see that there is a sequential order of the month. It can define within the function is print f. That is means percentage 0 to and d. That means percentage d means it's define the integers, and 0 to means its arguments it's two digit, the vector in two digits. So you can see that 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6 like that up to 12. So if I run this code, it automatically takes the monthly data from the folders. It's mirrors. Okay, we should first read the raster data. It's running. So you can see the annual average are done already from 1982 1981. If you change the path, suppose I create one folder here. Folder here. So you can see that it's come another folder. So I set directory to this annual average NDVI file to go to the another file. Okay, you can set as you can. Then come to the correlations for spatial data. So I have you already know that what is the correlations. It's basically define the relationship between two variables. So I have taken here two variables, that is NDVI and there is Nino index. Okay, so it is the 40-year one average for August month, and for 40 years average for the August month. Both are.
Uh, Debashish, so sorry to interrupt. Just wanted to let you know that we are nearing 4:30. How much time would you require to cover the pointers?
I will take 10 minutes only.
Okay, please ensure to end it in 10 minutes so that we can give the participants some sort of break before we move on to the next session.
Okay. So if you run this code, uh, it's uh, it's came as plot Pearson correlations and p-value, which is the range is between the -1 to +1, and p-value is mainly define the uh, significance test. Okay. Then I come to the man candle test analysis. So what is the man candle analysis? It is a train analysis, which can be used for climatological uh, climatic data which are trained or not trained. Okay, it can be it can different aspects, and there is shown in which data will be show monodic trends or not. Okay, it's basically non-parametric in nature. The tau, which is test statistics, define the trend directions, whether it's positive or negative. Positive for increase and negative for decrease. And then p value, trend significance. The with the smaller value, uh, it can define as significant trend or otherwise non-significant. Okay. For this is for mankind test analysis code. Okay. If you run, so for this mankind test, I have taken soil moisture data from for monthly. Okay. So if you run this code, it takes time somewhere. Okay, it will take a few minutes. So I will show another software, that is Panoply, which from here you can visualize the SDF, NCDF, and uh, grid data here. So I will show you how to plot here. This is a global soil moisture, volumetric soil moisture content. So this is the legends where you have to correct these legends. Okay, so go to the plot. You can increase your size or decrease your size as per your requirement. Okay, you can you want to show the your regions uh, as you wish. So here you can see your data, which is shown according to coordinate wise. So none value means no data. Okay, I see that. So it's running. So in this way, you plot the plot here. You select fraction, you take fraction 1, then it's came to the original value. Okay. Uh, so it's range between 0 to 0.8. You can change your color code according to, you can change this color or also this color. So this is the software where you can plot netcdf, sdf, and grid data format. So you can use this. How it's plotting. This is the Mann-Kellner train analysis plot. Okay. Okay, thank you. It's my end. Hello. Hello.
Hello, Deva.
Yes, I am audible, sir.
Yeah, you are audible very much.
Yes, he has completed actually.
Yes, I have completed, sir.
You have completed. I understand. Okay. So it's now 4:36. So we can break. Devasis will be available for some time. If you have any questions, I think probably you can. Devasis, you be here for just after this break, maybe around 10-15 minutes or so, till 5 o'clock or so. So that at least if they have any issue, they can discuss with you.
Okay.
Otherwise, we will break now for around because our next session starts at 4:45. So we are already 4:37. So we can break, say 10 minutes. We will be here at 4:50. Okay.
Okay, sir. Okay.
Deva, thank you. So you stay for some time so that at least after the break, if they have some query, they can ask you. Okay, those who are there, Dr. Bappa has shared some files with you. So some YouTube, you can just check it, or you save it for some for your yeah, you can save and then look into that at later time. Yeah, this is okay. This is an YouTube, sir, YouTube presentation.
YouTube video for ANC file.
YouTube
Somewhat,
yeah, NC files. Okay. So you can check it later on, no problem.
Sir,
Yes.
hello.
Hello.
Please, is there a possibility to have the first code in this session just to practice today, or shall we have this all these codes in the end of the sessions tomorrow?
Okay, this spatial analysis which Dr. Bappa has taken first
Yeah.
class.
Yes.
Okay, Bappa, can you share the code?
Sir, I have already shared it in that RP folder
RP
with the
files. Okay.
data.
Okay. Okay. Thank you. So, Nabil,
Yes.
you please keep in mind because Jinath is out for 5-10 minutes. So once he joins, okay, I will ask her because this is already been shared. So, but it is with Jinath. So I don't have access right now. So
Okay.
maybe she will answer, but that is there. Dr. Bappa has already shared, so you will get it.
Okay. Thank you.
Hmm.
Devashish Roy, you can unshare your presentation or unshare your screen.
Nabil, I have shared the code here also. From chat, you can download it. But data, it is there in that folder.
I am seeing some codes shared by Bappa. There are two codes. Introduction to R and R for spatial analysis. Whether Pooja has already joined, Dr. Devashish?
No, I don't think she has joined because it's too early, no, there.
Yeah.
So she is in US, so for her, I think probably it's around 4:15 or so. She's in the west side also, no, California.
I've joined the meeting, sir. Can you hear me?
So, but she knows that she will be joining.
Oh, Pooja is already joined.
Can you hear me, sir?
Pooja is already joined, Dr. Devashish, from USA, western part, California. Yes, I am listening to you, Pooja.
Yes, we can hear Pooja very well. Devashish, are we continuing with the session for Dr. Priyavat and Dr. Pooja Singh, the joint session?
Yeah, it will be started at 4:50 as discussed because there is a break. So
Right.
just starting, we are ensuring that whether my co-partner for the next session has already joined or not.
Okay, okay. So we can Pooja, we're having a break for all the participants because it was a long session. We'll be starting in another 7 minutes or so. Just give us time. I'll also request other participants to mute their mic, excluding a lot of disturbance. No, I do not have. Devashish, do you have the right to mute everyone? I'm not a host. Sangeeta, I see you are the host. Can you please mute your participants?
Hmm.
Sangeeta, are you there? Sangeeta, can you please make me the co-host? I see that you are the host, so could you please
I'll
make?
try. I'm the host. Okay.
Yeah, I don't know. I don't know how the host rights have been transferred to you. So if you can make me the host actually,
Yes,
and
I
that
think
would
that because of Vivek's leaving, it automatically changed to another participant. So, if
yeah.
she can make share the host with using that will be awesome.
Yes, Sangeeta, can
Ma'am,
you please?
how can I make you the co-host?
I
Can
think when you
can
click
you
on my
please
name in the chat, you'll get it in under
okay.
more options. Yeah.
But maybe give Sinat the host, not the co-host, please.
You can go to the click on the participants and you can see the name and here
I made you host, ma'am. I made you host. Please check once.
Okay, great,
Yeah,
great, great.
Jinath,
Thank you
you
so
are
much.
now host. You are now host, Jinath.
Okay, great.
Yes.
I have made you the Bashish the co-host.
Yeah, okay, no.
Okay, okay.
So I told them to be back at 4:50, so 3-4 minutes are left.
Okay. I've also made Larissa the co-host. Let them be back.
Mm-hmm. Yeah, let them be back, and I think Dr. Satra he is here, so he can continue after 3-4 minutes.
Sure.
So I had one query for Dr. Santra. If he's available, can I please ask him?
Yes, sure, you can ask him, no problem.
yes, sure. I am here now.
Okay, sir. Okay, sir, good evening. Actually, very basic question. The initial analysis which you showed using that X, Y, and flood frequency data. So, sir, is that X, Y data latitude, longitude data, or what it is, sir?
It is in the meter coordinates.
Okay.
And it is the actually data given in the spatial package of R as a demonstration file, and this data is from Germany on Meuse River. So in Germany, using different projection system and different coordinate reference system, but it is in meter, not in lat long.